Hey everybody, Mr. Johnston here. In this video we're going to talk about density. We'll go over what is the definition of density, a couple of practice problems, and we'll also talk a little bit about particle diagrams. So first, the definition of density. Density is the ratio of a substance's mass to its volume. Density has the formula that density equals mass divided by volume. And we can abbreviate that D equals M divided by V. The units on density are always mass in the numerator and volume in the denominator. A lot of times you'll see grams per cubic centimeter or grams per milliliter, but this could really be any mass like kilogram, pound, or any unit of mass, and volume. So you could do kilogram per liter. You could do pound per gallon. And so you can have various units for density as long as it's mass on top and volume on the bottom. Each substance has a unique density, and those unique densities can often be used to identify a substance. And so this table right here shows some common densities for substances that you may be familiar with. Some things have rather low densities, like ethanol has a density less than 1. It's 0.789, while some things have very high densities. Something like gold or platinum, way down the bottom of the chart, has densities, platinum is over 20 at 21.4. And so we've got a whole range of densities out there. And if you know the density of a substance, you can oftentimes compare that known density to the chart and see what substance you might have. Solving some density problems. Sometimes this can be real straightforward. Like if you are given the mass and the volume, you simply have to plug the numbers into the density equation. In other words, you just divide mass by volume. So here's a quick example. An object has a mass of 22.5 grams, a volume of 2.38 centimeter cubed. What is the density? So I have the density equation. I plug in those values. Again, we're plugging in this mass value. Oops, that didn't work so hot. We're plugging in this mass value, and we're plugging in the volume. I should probably not try using that. And you end up getting the final density, of 9.45 grams per centimeter cubed. Sometimes the density problems can get a little trickier. For example, if you are given density in one of the other variables, either mass or volume, then you're going to have to use algebra to solve for the unknown variable. And here's my example. Acetone, or nail polish remover, has a density of 0.7857 grams per centimeter cubed. What is the volume in milliliters of 6.54 grams of acetone? So in this case, I have both the density and the mass, and I need to find what the volume is. So what I've done is I set it up where I plugged in the known values, and then I'm going to use algebra to solve for the unknown, in this case, volume. And so I'm going to multiply both sides of the equation by volume, and I'm just using the placeholder V. And notice that if you multiply by volume on the right side of the equation, volume cancels. And what you're left with is volume times 0.7857 grams per centimeter cubed equals, in this case, the mass, 6.54 grams. We still need to get volume by itself, so there's one more step. I have to divide both sides by that density value. The density cancels this time on the left side, and what you're left with is volume equals 6.54 grams divided by 0.7857 grams per centimeter cubed. And what you're given then, once you've plugged that into your calculator, is the final volume of that acetone. And so you'd have 8.32 centimeters cubed, or if you were measuring in milliliters, that would be 8.32 milliliters of acetone. One other quick note, sometimes you have to determine the volume before using it. So if you're given like length, width, and height of an object, you can use that to find the volume. Or another time, sometimes you're also given like displacement data, where if you have an object in some water, that object is going to push the water to a higher volume, and the difference between the water without the object and the water with the object is going to be the volume of the object. So sometimes you're given information about displacement. Sometimes you're given information that you need to find the volume from length, width, and height. One last thing about particle diagrams. The spacing of particles can be used to show density. So if you have something that's a low density, you might do a particle diagram where the particles are really spread out. If you have something that's more dense or a higher density, you would pack those particles closer together to show higher density. You are going to have a quick homework assignment where you're going to do a particle diagram of some various things and show their relative densities. If you have questions, of course, let your teacher know, and Ms. Javner and I are happy to help.